Alright, I'm making this video to show you guys how to create a macro for the integrated circuit. So today I was thinking, hey, I never tried one sample class D audio amplifiers. So right now we have this integrated amp audio class D. So we have the package here ready to go. I believe this is the heatsink that you're going to place, or you will screw the heatsink right there. I think on DigiKey you can find the perfect heatsink for that application. So we have this audio amplifier. It can deliver, it says 420 watts by to 8 ohms low, or 210 watts by 2 4 ohms low speaker. It will work from a 12.5 volt up to 45.5 volts. So I was reading the data of the, how you say, the legend, the guide, so you can start to put it together. One second, hold on. I think this, I was doing this one here. This is the one. So this is the legend. As you can see, the wire, the leads. What the hell is going on here? Someone's going on. Oh, okay. So someone writing something. All right, sorry. I apologize. So we have the front of this package. It's showing the how it's going to be. This is the orientation. Let me zoom here better. All right, so we have the distance between where are going to be soldered to the surface top of the PCB. So we have the E. So we're gonna look for it. E on the, what? Someone is writing something. What? Yes, yeah, man. Oh Lord, have mercy. You know, I just saw the welding machine today. So all right, so let's continue with this. So we have the E. I see some kind of a separation. I think it's something else with the heatsink. All right, so we have the E. We're gonna look for E on the table. E, capital letter E. So we're gonna look for that. It says 13.90 or 14.50, the minimum and maximum. So I will just round that number to 14, and that's it. You don't have to go crazy to be that perfect. So here, as you can see, if I create the paths with the tool, the footprint wizard is right here. So this is the footprint wizard, and from here I create that particular layout for the paths. You don't have to do it manually, but that will be not accurate. So for example, here are the numbers. I just type the numbers here. I choose dual row DIP, deep component. Here the distance is 0.65 between them. So that's the distance I'm going to show you right quick here. So I'm going to move this window here. So you can see the distance between the solderable surface path is 0.65 as I place it here. And that's number, that will be the letter D. That's the letter D, and the letter Y is the 14 millimeter distance between them. If I use the ruler or measurements tool that is here, you can see like a little white ruler. You can measure that and see that it's actually a 0.65 millimeters. 0.65 millimeters. So right now I'm going to measure from this pad to the bottom, and it's 14 millimeters. So we know that is correct. Also, you can edit the thickness. I don't think it should be a good idea to make it way too wide, because it might create problems. You can make it thicker. One sample, you can make it, but it's not a good idea. I say 0.40 is fine. 0.40. What the hell is going on? Okay, all right, let's continue. So, since this is an integrated circuit, the traces, they are going to be a little thinner than we are used to. Actually, I'm working with simple audio amplifiers. I'm sorry about that. God damn it. I'm thinking that they are simple audio circuits. I'm thinking it's because the traces are really thick, but in this case the traces, they are going to be really thin. This one is 0.30. You cannot make it 1 millimeter because it's gonna look like this. One example, I'm gonna place one here. As you notice, when I place the trace, I place it in the middle of the path. I do not place it here. As you can see, it's not how you say grabbing the middle. You gotta place it here in the middle of the path, so then you can correctly trace that I don't know, particular connection, whatever. One sample, you're gonna connect it here, whatever, you know what I mean. So this is a 0.30 millimeters. So if you are going to change it to 1 millimeter, you cannot do it because it's gonna look like this. You see, bulky. It's not gonna work. It's not gonna work. So you gotta make it 0.30. 0.30 is just fine, but it's going to have really thin traces because now we're working with the integrated circuit. So the traces there are going to be really small traces. So actually, on this circuit, one example, if I wanna, and maybe in the future, I don't know, maybe in the future I wanna make like some kind of Class D small audio amplifier for my computer, so I can do it here. So sorry about that. There you go. Sorry about that. I was moving the microphone. I apologize for that. So and then you can make a small circuit for your computer, a Class D amplifier. This one will deliver. Let me see. I remember. I forgot. 200 watt. That's too much. 210 watts. So that will be like 100 something watt to 8 ohms low. So maybe in the future, I don't know. Maybe in the future I might get better. So okay, one thing, I'm gonna send this to my friend, Mr. Stewart, so he can look at it. So use it as this is just an example, a reference. So I'm gonna send it to him. This is just an example. Okay, this is the example. Measurements. Sample. Okay, samples. Okay, samples. All right, cool. That's fine. Samples. Right there. I'm gonna save it so he can look at it. And now we're gonna split this group. So that means that if in the future I'm gonna create a Class D audio amplifier, I have to use a surface mount devices for this application instead of using a through hole components. So that will be a big difference right there. Oh yeah, I forgot to show you the footprint wizard. I already got it set up, so I'm gonna use it one more time. And I notice here, I think I gotta change the thickness of the paths because they are touching each other, as you can see here. So I gotta change it here. It's 0.40 and 0. Let me see. I think I can make it longer. I think it will be easier if I make them longer. So that will be it will make the soldering a lot easier that way. I can do it that way too. I think I can do it. One example, I'm gonna change it. I'm gonna make it longer, so that will help. No, I think it's fine like this. 1.50, the length of the pad. Okay, so it's gonna look like this. Let me see. I'm gonna place one here. Hold on, give me a second, guys. So that will be this one here, this surface mount. So it's gonna look. You see, you cannot do it by hand. You have to use the tool. You gotta use the tool so you can make it accurate as possible. Also, it's a bit difficult to center out the full screen, the representation of that particular component. I try to make it as accurate as possible, and this one here is the length is 60 millimeter by 10.5. I think it's fine. 10.5. It's just it's gonna be covered up with the integrated circuit anyway, so it's no big deal. You wonder how did I place all these sort of like a representation of the lead of the wire to be the same accurately. One sample I'm gonna show you how I did it. So I'm gonna delete this one here, and then what I did, I just placed it in the center. One sample, I'm gonna copy it. I'm gonna make it longer. I'm gonna put it in the center. But let me see. There you go. So it's right there. As you can see, the center of the pad right here, it has the its own. God damn it! I don't know how to say it. Jesus Christ! Hold on, guys. Its own. grid, 0.0 grid, 0.0 grid. I think that's the best way I see it. All right, fonts. I gotta change this. It's a little ghetto, but it's fine. There you go. Its own grid. So basically, you're gonna use this to screen. You're gonna move it, and you can see if you hold the left button of the mouse, is going to when you move it, it's showing you where he want to grid from somewhere. So I'm gonna grid it right here, and every time I do it, it's gonna be accurate all the time. You can see I can keep doing it, copy it, place it here. You can see all the time. So let's continue doing that until I complete it. Let's continue doing that. Or to make it faster, let me see, 0.65. Let's do that. Let's make it faster. I mean, you don't have to do that manually all the time. This takes too long. So, for example, the distance between the pads are 0.65. So we had 18, and the distance I'm gonna type it here, 0.65. 0.65, and then we need 18 of those. 18 of those. All right. We're gonna type 18, and then I'm going to press OK. So everything is automatically done. So one example now, I need to move. What the hell? We're making it. Okay, trying to make a video. Okay, I'm gonna split the group, and then I'm gonna move this down, and then I can edit that later. So there you go. That's fine right there, I think. Yeah, I think it's fine. I'm gonna split it. Oh yeah, hold on. Oh yeah, I should done that. Yeah, I made a mistake, guys. Sorry about that. Let's be more how you say, more accurate. Not to waste time. Let's do it. You don't have to do it manually all the time. All right, one sample. We're gonna clone this line. This is sort of like a full screen representation. It can be like this also. You can make it like this. You see, you can make it like that. You can make it a little thicker. You want to? Yeah, let's go with 0.30. 0.30. No, we got a little problem here because it's too thick. So that means I gotta increase the size of the rest. Okay, 0.30 is just fine. 0.30 can be 0.20, but since I made this one thicker, I gotta change the other so you don't see that little ball right here. All right, so we're gonna copy it one more time. We got 18, a distance between them 0.65, and then I press OK. So this already done, created. So and then I'm gonna edit this one because I edited the top one. So I'm gonna copy it and place it down there. So that's the thing I wanna do. Build a group. I think I did build the group already. Sorry about that. I'm gonna copy that, and then I'm gonna place it here. So I'm gonna look for the center of this so I can move it, and you can see it has a accurate leads representation right there. So it's gonna look like this. This is a surface mount device. So the solder is going to be on the top. It's going to be on the top of the circuit. So let's see. Let's see on X-ray. Okay, so we got it like this. And you can see the traces, they are really thin. I do not make a really small integrated circuit yet. Not yet. Maybe in the future. I might create a Class D audio amplifier. I'm not sure. So that's the way to do it really fast. And we got the distance, and from here to here, from these two pads, 0.65 and 40 millimeters. Yeah, you gotta keep pay attention to the legend. I call this one the legend. Okay, we got. I was looking for, okay, how many leads I have here. So this is the lead number 1 right here. We got 18. So you just multiply by 2 and we got 36. So, and then the distance between the leads is this one here. I gotta show you guys. Hold on, guys. All right, so we got it here. The distance between the leads is letter E. So we're gonna look for the table on the table for letter E. So we're gonna look for letter E. Okay, right here, letter E. You notice it's not telling you, okay, it's not telling you minimum or maximum. It's just a fixed number. It has to be 0.65. It cannot be less or more. It has to be 0.65, the distance between the pads. So it's really important. Now the one sample, letter E, capital letter E, is telling you that this is the area where the pad is going to be soldered. So we need to have it, this one does not need to be perfect, does not need to be. Oh, it's telling you also the distance between the soldable area. You can see L, letter L right here. So we're going to look for letter E. Sorry about that, I gotta make sure I always do that. Okay, we got letter E right here. So now we're gonna now like we say in Puerto Rico, me salió un gallito. Okay, so we're gonna look for letter E, capital. So it says minimum is 13.90 and maximum 14.50. So makes sense to just round that number to 14 and that's it. 14 millimeters. It's fine. We got 14 millimeters. So right now we're gonna place the one more time. I just gotta keep. It's like drilling, like in the army. Okay, one sample here to here. We got 14 millimeters, so it's fine. And the pad you can make it a little longer, so it will facilitate. I say it will be a lot easier. Okay, hold on, guys. Be a lot easier. Did I spell that? To solder there. It will be a lot easier to solder the pads because you have a longer pads, because the I think the wire they're going to, one sample I'm gonna do it right here. One sample the leads, one sample this is the, I'm gonna make it with the accurate size. Hold on, give me a second. Thinking. Okay, so it says on the legend, the drawing of that particular component, it says it has a 0.12. 0.12, that's really thin. Okay, 0.12. Let's see, let's do that. The wires are 0.12. that's the wire. Let's see if this is possible. Hold on. Oh man, that's a really thin wire. It's a really thin wire. 0.12. Oh Jesus Christ. Okay, one sample. This is the wire of the integrated circuit. So we're gonna place it. It's going to be placed here. Hold on, give me a second, guys. As you can see, that's the area that is going to be soldered. You know, there is one technique. You put some flux, and then you just drag your iron. You will drag the iron. It's gonna solder everything automatically, really fast. So it's gonna have like a shiny balls. Sounds funny, but anyway. Gonna make it like this. This is like a solder balls. Each one will have the, for example, right there. I'm gonna make this like a illustrating the solder area. So it's gonna have like this. I mean, it's not gonna look like that. Maybe it's gonna look shiny. It's not gonna like a rectangle, shiny rectangle. For example, let's do the same thing. So it's gonna look like this. It's gonna solder all those devices with the dragging technique of the hot iron, a 0.25, a 25 watts a hot iron tool. So it's gonna look like that, and so we have plenty of room because we make this longer, so that will facilitate. Will make it easier to solder. If you make it really like this, it might be really difficult to try to align. The components it might be really difficult to align it because you gotta place it exactly there. So if you make it longer, a little longer, don't go crazy, just 1.5 should be just fine to be able to solder that, because we know that the distance between those leads are 40 millimeters, the maximum 40 millimeters, as a right here. You can see right here, that's the distance. So this, this area, sorry about that, guys, gotta zoom here. Ay Dios mío, Jesus Christ. All right, so this is the area there's going to be in touch with the PCB. So this area, you see this corner right there, that's where you're going to place it, right here in the middle of this path. All right, I guess you guys got the idea. All right, so that's it. I'm going to send you this one here too. It's example build group. I'm gonna send it to you so you can use it as reference. Example 2. All right, cool. That's it. Example 2. All right, that's it. All right, I'm gonna cut the video. I think this also teach me a lot, because I never thought that I wasn't never thinking that I can figure out stuff like this, because I never studied this in the school or something like that. I might get better by time. I'm not sure. I might do something different instead of making just through holes circuit and having a integrated circuit instead of through hole devices. I think I might try. I'm gonna practice that. All right, that's it. I'm gonna cut the video. I hope this is helpful for the guys that also do a integrated circuit. I don't do much integrated circuit. I'm going to figure out. Let's see if maybe in the future I might build a simple Class D amplifier, surface mount a Class D audio amplifier. I'm not sure. I'm up to through hole devices. All right, that's it, guys. I hope you like this video. All right, have a good day.